I welcome you all, dear students. We are discussing some most important questions which are for electromagnetism. And here we were. This is the alternate answer of the previous one. That is for a positive charge Q, velocity V in uniform magnetic field. The magnitude of the force acting on a charged particle when it enters an arbitrary angle with the field is QVB sine theta. And here it will be no magnetic force and charge follows the rectilinear path. If it enters at 90 degrees, it follows a circular trajectory. For angle that is greater than 0 or less than 90, charge particle experiences a magnetic field and it follows a helical path. So stepwise it is clear what will happen if with the value of the angle at certain value when a charged particle moving with velocity v interferes with the magnetic field B. Here we are. An electron does not suffer any deflection while passing through a region. Are you sure that there is no magnetic field? If electron is not feeling any type of the deflection, what does it mean? It means that there is no magnetic field. So here it is no. Why? Because we can't say that the magnetic field is in a certain region of space is zero, in which the electron suffers no deflection, because already we have discussed in the previous problem. Here it is the magnitude of the magnetic fields of the electron of charge E moving with the velocity v in a magnetic field B, that is F is equal to QVB sine theta, and this angle is between Q and B. So theta, if the theta is 0, it means then no force is acting, although there is magnetic field. But the charge is entering at a position which is parallel in the direction which is parallel to magnetic field. Angle is 0. This shows that the magnetic field is there, but no force is acting. So the question is, the answer for this question is no. Although there is magnetic field, but it is necessarily depending on, it is the most important thing to remember that this depends on the value of the angle at which the charged particles enter in the field. If the angle is 180 degree, then again there will be no force acting because sine 90 is sin 180 is 0. So it means opposite to the magnetic field. If there will be a magnetic field, but the electron in either moving parallel or anti-parallel, angle 0 and 180 to the magnetic field, then in such condition there will be no magnetic force on the electron and hence suffers no deflection. And the second possibility is that if the electron is allowed to pass through cross electric field of the magnetic field such that both cancel each other effect, then under such condition the electron does not suffer any deflection. Presence of magnetic field is mathematically, this one is magnetic and electric field. It enters in such a way so that they are opposite to each other. They cancel each other effect. So the magnetic force acting will be equal to electrostatic force. This is the magnetic force and this is the electrostatic force. When this charged particle is moving inside the magnetic field, this is the force acting. And when this charged particle moves in the electric intensity, this is the electric force acting. So this V, E is cancelled with this E, and this V is equal to E over B. Thus both B and E are constant and the beam of electron will move with constant velocity without any deflection, because these two are constant. E and B both are constant and there will be no effect at the end on the velocity of the electron. It will keep on moving with constant velocity. So this is the basic concept. What happens when you move any charged particle inside uh, magnetic fields? Does it suffer any type of deflection or not? Again, move back to the question, that is, an electron does not suffer any deflection while passing through a region. What does it mean? Electric field is there or magnetic field is there or not? So this was the answer on the basic on the basis of mathematics. Along with the sport of mathematics, we have proved that Although there will be magnetic field, but there is possibility that no force will be acting on the charged particle and it will move with the same velocity without any change. So moving ahead for another, that is an electron beam passes through a region of cross electric and magnetic fields E and B respectively. For what value of the electron, speed of the beam will remain undeflected. An electron beam passing through the region of cross electric and magnetic field will remain undeflected if the electron moves with constant speed. When the two fields are so adjusted that electric and magnetic force on the beam balance each other, then the net force will be zero. Here it is. It means that the electric magnetic field force and the electric force, their sum is zero. They are cancelling each other. So as a result, this magnetic force is equal to the electric force. So in between, if you look at this, Q is cancelled with this Q. So VB, that is equal to E, and this V is equal to E divided by B. E and B both are constant for that type of the field. These are not changing for that certain region. E and B both are constant. So when electric field and the magnetic field are both constant, then the velocity of the beam will be constant and will not be affected and will not be deflected. So this is the authentic type of the answer. So when an electron beam passes through a region, here it is, through a region of cross electric and magnetic field E and B respectively, for what value of the electron speed the beam will remain unchanged. So this is the answer. This is the only possibility when the electric and magnetic force which are cancelling each other, they are having same magnitude but opposite. So that's why magnetic force and electric force, their sum is zero. So it means that the magnetic force is equal to the electric force in that region. Whenever a beam of electron is passed through that region, and it will pass with a uniform velocity without any change of the constant velocity. Why? Because E and B, electric and magnetic field, are not constant. They are not changing. So this is the reason why why the velocity of the beam will remain the constant, and there will be no change. So this was the question. An electron beam passes through a region of crossed electric and magnetic field E and B respectively. For what value of electron speed the beam will remain undeflected. So this is the logic, and this was the main reason. On the basis of mathematics, we have explained it in detail. What will happen with the velocity of the beam? It will remain constant. There will be no change because they are cancelling each other. They are the two forces which are equal and opposite. I thank you very, thank you very much.